Hello viewers, in this session we will discuss about numerical based on IS mix design, and you will require Indian Standard 10262 2009 and Indian Standard 456 2000. Let us start our example number 2. We have to design a concrete mix for M40 grade of the concrete mass, and the characteristics and the properties of the ingredients of the concretes are: the types of cement is OPC 43 grade, maximum size of aggregate which is 20 mm, exposure condition is severe, workability 100 mm slump, maximum water cement ratio is 0.45, method of concrete placing is good, type of aggregate we have to use crushed angular aggregate, and maximum cement content 450 kg per meter cube, chemical admixture type is superplasticizer, specific gravity of cement is 3.15, specific gravity of fine aggregate is 2.74, specific gravity of coarse aggregate is 2.74, water absorption of fine aggregate is 1.5 percentage, and water absorption for coarse aggregate is 0.5%. We have to consider for the fine aggregate zone, which is zone 1, and remaining data you can assume the suitable based on Indian standard. So this is all about the requirement of mixed design. Let us start with our first step is to finalize the target mean strength of concrete. As we know, the target mean strength F-CK is equal to FCK plus 1.65 into S. S means the standard deviation of concrete mass. You can see our FCK, which is the characteristic compressive strength. We have to design the concrete mix for the M40. It means FCK value will be 40 and the S value means standard deviation value we can easily take from this table, which is dependent on the grade of the concrete mass. Here we are doing mixed design for the M40 grade of the concrete mass. So we have to take standard deviation value is 5.0. So we can easily calculate 40 plus 1.65 into 5 for the M40 grade of the concrete mass, and we can easily calculate the target mean strength of the concrete, which is 48.25 Newton per mm square, and this table has been given in Indian Standard 10262 2009 table number 1. After the finalizing the target mean strength, we have to finalize the water cement ratio, and as per the data we have to take the severe condition, and for the severe condition we can take maximum 0.45 for the water cement ratio, and here you can see for the severe condition we have taken water cement ratio 0.45, but based on the experience we are also taking the water cement ratio 0.40. So we are taking the list of above two values and we are taking the water cement ratio which is 0.40, and this table has been given in Indian Standard 456 2000 table 5. So after the finalizing the water cement ratio, we have to calculate the water content, and as we know Indian Standard 10262 2009 table 2 has been given maximum water content based on the nominal maximum size of the aggregate. It means you are using the 10 mm size of the aggregate. You can take the maximum water content 208 liter. So based on the data, we have to use the 20 mm size of the aggregate. So we can take maximum 186 liter for the water mass. And in the data, the slump value has not been given, so we are considering 100 mm slump mass. And as we know that this table for the 25 to 50 mm slump range of the workability, and after the 50 mm, every 25 mm slump range of the workability, we have to add 3%. It means 50 to 75, we have to add 3%, and 75 to 100, we have to add more 3%. It means for the 100 mm slump, we have to add 6% of existing value. So we have taken 186 liter from this table, but this value for the 50 mm slump, and we have to correct this value for the 100 mm slump. So we have to add 6%. It means 106 divided by 100. It means our value 197 liter of water mass. And we have to also do correction regarding the superplasticizer. As we know, with using the superplasticizer, there will be decrease the requirement of the water mass 20% or more. So assume that the 25% reduction in the water in content due to the superplasticizer. After the reduction of the water content due to the plasticizer, our water mass will be 148 liter. So after the finalizing the water content, we have to calculate the cement content. And as we know, we can easily calculate the cement content with the equation of water cement ratio. And we have taken the water cement ratio, which is 0.4, and water mass, which is 148 liter, and water cement ratio is 0.4, and from this calculation the cement content will be 370 liter kg per meter cube. But we have to check this value with the minimum criteria of Indian standard, and based on the data we have to take the severe condition, and based on the severe condition you require at least 320 kilogram per meter cube, but we have taken 370 kilogram per meter cube, so it's okay. Otherwise you have to take greater of two values. Our next step is calculation of coarse aggregate and fine aggregate. Consider zone 1, and you can see the table which shows that we have different zone, and these values is values of coarse aggregate of total volume, and here in this column you can see this is the nominal maximum size of the aggregate. So you have to take the volume of coarse aggregate based on the zone and nominal maximum size of aggregate. Here we consider zone 1, and we are using the 20 mm size of aggregate. It means we have to take the 0.6 volume of coarse aggregate. So we have taken the coarse aggregate value is 0.60, but we have to correct this value because this table for 0.5 water cement ratio, and we have taken 0.40. It means there is a difference of 0.1 for water cement ratio. So we have to increase 2% of coarse aggregate. So coarse aggregate will be increased by 2%. It means 0.6 plus 2%. It means 0.6 plus 0.02. Now our final value will be 0.62. It means you have to take 62% of coarse aggregate. So fine aggregate will be 1 minus 0.62. It means you have to take the value of the fine aggregate 44% of the total volume. So after the calculation with the correction of the coarse aggregate and fine aggregate, now you have to finalize the mix proportion. As we know, we are doing mix design for the 1 meter cube and volume of water we have taken 148, and we can easily calculate the volume of the water, and we can easily calculate volume of cement, which is 370 kilogram divided by specific gravity of cement. It means 370 divided by 3.15 multiplied by 1 divided by 1000. It means our volume of cement will be 0.117 meter cube. And then we will calculate the volume of chemical admixture, or you can say super plasticizer. Consider we are using 2% by the weight of the cement mass for super plasticizer, and we are assuming the specific gravity of the admixture of 1.1 for the super plasticizer, and we can easily calculate of the volume of chemical admixture or super plasticizer. So we have volume of super plasticizer is 0.0065 meter cube. So our volume of concrete is 1 meter cube, volume of water is 0.148 meter cube, volume of cement is 0.117 meter cube, and volume of chemical admixture is 0.0065 meter cube. And as we know, in our concrete mass, we are using the coarse aggregate, fine aggregate, water mass, admixtures, and plasticizer and super plasticizer. So we have to find out the volume of aggregates. So we have to deduct the volume of water, cement, and admixture of the total volume. So we can easily calculate the volume of all aggregate. So 1 minus 0.148 plus 0.117 plus 0.0065, it means volume of aggregate will be 0.729 meter cube. And based on the previous data, we are taking 56% of the total volume of coarse aggregate and 44% of the fine aggregate of the total volume for the fine aggregate. So 0.729, which is the total volume of aggregate, and multiply by 0.56, which is the 56%, and multiply by 2.74, which is specific gravity of coarse aggregate, multiply by. So we can easily calculate the mass of coarse aggregate 1118 kilogram, and then we can easily calculate the mass of fine aggregate with 0.729, which is the total volume of aggregate, and multiply by 0.44, it means 44% of the total volume, multiply by 2.74, which is the specific gravity of fine aggregate, multiply by 1000. It means we have a 879 kilogram of mass for fine aggregate. So our next step is mix proportion, and we have a cement mass 370 kilogram per meter cube, water mass 148 liter. So our water cement ratio is 0.40. We have a fine aggregate 879 kilogram per meter cube, coarse aggregate 1180 kilogram per meter cube, and chemical admixture is 7.4 kilogram per meter cube, and weight density of concrete is 2522 kilogram per meter cube. Our next step is site correction for the water absorption and surface moisture. So we require correction regarding water absorption and moisture content for the aggregates. So there will be effect to the mass of water. As per the data, the water absorption of fine aggregate is 1.5 percentage. So we have to calculate 1.5 percentage of coarse aggregate. Our coarse aggregate mass is 879 kg. So 1.5 percentage of the 879 kg, our final value will be 13.18 liter. It means 1.5 divided by 100 multiplied by 879 kg. So we have a 13.80 kg, and you can also say that 13.18 liter for the water mass. And for the coarse aggregate, water absorption is 0.5 is given in our data. So 0.5 percentage of the mass of the coarse aggregate is 5.59 liter. So calculate this value 0.5 divided by 100 multiplied by 1118 kg, and total absorption will be 13.18 plus 5.59. So total value will be 18.77 liter. So actual mass of fine aggregate will be 879 minus 13.18, because 13.18 is a absorption by the fine aggregate. So total mass of the fine aggregate will be 865.62 kg, and actual mass of coarse aggregate will be 1118 minus 5.59 liter or kg. So we have a final actual mass of the coarse aggregate will be 1112.41 kg. Our last step is to finalize the mix proportion by weight. Here, as per the previous data, we have used 370 kg of cement, 162.38 liter of the water mass after the correction, and fine aggregate 865.62 kg, and coarse aggregate 1112.14 kg. So we can calculate this proportion based on 1 kg of cement. So with the 1 kg, water mass will be 0.438 liter, and for the fine aggregate we will require 2.34 kg, and for the coarse aggregate we will require 3 kg of mass. And then we have to finalize the proportion based on the 50 kg of the cement, because our cement bag is packed based on 50 kg. So you can see the proportion based on the 50 kg of cement. So this is trial based method, and after the finalizing the proportion of the all the ingredients of the concrete mass, you have to find out the hardened properties of the concrete mass. So you have to find out the compressive strength of the concrete mass at the end of the 28 days. If the strength is adequate, it means your proportion is okay. If you are not achieving the desired strength of the concrete mass, then you have to do the trials for the different proportion. So this is the trial based method, and you have to check it out for the hardened strength of the concrete mass. If you are achieving the desired strength of the concrete mass, it means your mix design is done. Thank you.